Today we're going to be talking about something called compound inequalities. Either it's going to be an AND statement or an OR statement. So we're going to read a few of the following statements. The first one here says, you will graduate from Old Orchard Junior High next May, and you will all begin high school at Niles West next August. For a compound statement to have an AND statement to be true, both of the simple statements must be true. However, since the one that I just read, one of them is false, even if you may be graduating in May, but the fact is that you are not starting high school at Niles West because you're starting high school at Niles North. That makes the whole sentence false, the entire sentence. Okay, even though part of it was true. Now, if we read the next one, it says, you will graduate from Old Orchard Junior High next May, and the graduation will be at Niles West. If you don't know, your graduation will actually be held at Niles West, so both statements are true. So since both statements are true, then the entire AND statement is true. And the word AND is something called a conjunction. We learned that in English class, right? Now, the next one, it says, you will graduate from Old Orchard Junior High next May, or you will get your high school diploma in June. Now, for this word or to be true, that means at least just one of the simple statements must be true. It not necessarily needs to be both of them needs to be true, but just one of them. And so since you are obviously not receiving your high school diploma in June, like this one right here, I'm just going to X out that one. That's not true, but because of this word or, and this is true, that actually makes the entire statement true. Okay? Now, the word or is actually called a disjunction. So a conjunction is with an and, disjunction is with an or. Let's turn to the next page. Instead of turning to the next page, if you scroll down a little bit, we keep on reading. When two inequalities like x is greater than -2 and x is less than 4 are considered together, they form a compound inequality. So as we've seen earlier, right, the word and means both of them have to be true, but an or can mean either is true. So an and in math, in terms of inequality, is an intersection. So if we have an intersection in the graph, like we've been practicing graphing earlier, right, the past couple of days, if there's an intersection between the two, then that means both statements are true. So what I want you to do right now is I want you to make a graph for this one and this one individually. And then in a few seconds, just pause it for now, and then in a few seconds, check your answers. So if you see here on the left graph, x is greater than or equal to 3, we just use our rules. Greater than or equal to means it's a closed circle. Since it is greater than, it is going to the right. X is less than 7, then it's an open circle, then it's being shaded to the left. Now, how do we combine these two ideas? So if we take this graph, look at this graph, and it says 3 is less than or equal to x, which is less than 7. Now, let's cover up the right side for a sec. If we cover it up, it's really saying that x is greater than or equal to 3, which is the same graph that we had before. So, you would have a closed circle at 3, and since, again, x is greater than 3, then it's going to go to the right, and that's what we have. Now I want you to cover up the left side and uncover the right side. Then we have x is less than 7, just like how we had the graph previously. And since, again, it's not equal to, it's open circle. And then we're going to shade it to the left. And so notice that there is an overlap in the middle here. This right here is the overlap. This is considered an AND statement. Let's turn to the next page. So let's do this first one together. The directions say graph the solution set of each compound inequality. Write the solution without the word and. So if we get rid of this and, How we would normally do this is we just, one sec. In order to get rid of the AND statement, put the x in the middle. Now, over here on the right side, it says x is less than or equal to 3. We're going to keep that one the same. But we're going to flip this guy. Because x is greater than -5, so that also means -5 is less than x. And so here's our compound statement without the word and. And so again, what I'm going to have you do is I'm going to have you cover the right side and then just work on the x is greater than -5 and then graph x is less than or equal to 3 and then you'll see that there's an overlap. So pause, take a few seconds, and then check your answers in just a bit of how your graph will look like. After you graph both of them, you'll realize that x is greater than -5, so it's going to the right with an open circle, and x is less than or equal to 3 with a closed circle, and it's going to the left, and you'll see that in the middle, that there's our intersection. That is the AND statement. Why don't you go ahead and try to pause for number 2, do that on your own. First, write the solution without the word and then go ahead and graph it. And in a few minutes, whenever you're ready, just unpause and check your answers. So if you check your answers here and combine it, x is between -4 and 6. -4 is strictly less than x, but x is also less than or equal to 6. So if you graph those separately, you will realize that they intersect somewhere in the middle, just like how it does below. If you still need some practice, why don't you take a pause and or rewind the video and maybe rewatch some of the examples that were done before. Otherwise, let's jump to number 3. Number 3, before we graph it, we got to get y by itself. And so again, what I'm going to do, I'm going to cover up the right side and start solving. When you do that, add 3 on both sides, you get -8 is less than or equal to y, or y is greater than or equal to -8. Now, you can graph it first if you want to, but you can't forget about the right side. So what I'm going to do now is I'm going to erase the work that I did, keep the green stuff, and cover the left side and uncover the right side. Cover the left side here, uncover the right side, and then solve. After you solve, you get this compound inequality. -8 is less than or equal to y, which is less than or equal to -5. Now, if we were to graph this separately, we are really saying that y is greater than or equal to -8, just like that. But it is also, y is also less than or equal to -5. And so after we graph those individually, you'll notice that there is an intersection again in the middle. Why don't you go ahead and try number 4, make a compound inequality first, right? Just one long sentence without the word and. Solve for r, and then try graphing it. Pause the video. After a few minutes, go ahead and check your answers. If you have any questions, just bring them tomorrow. So you'll realize that I kind of did them separately before I combined my compound inequality. That's completely acceptable. Now I'm going to go ahead and graph it. After you've graphed it, you'll notice that they intersect together. So we've talked about the AND statements that intersect. Now we're going to talk about the OR statements. These are a little bit simpler. You'll have x is greater than 2 or x is less than or equal to -1. Now there's actually not really a short way of writing this, like how we were able to combine the inequalities before for the AND statements. So you'll really just see these OR statements. And so you'll just have to, if we graph these separately and then combine them, we'll see what the graph will look like there. So what I want you to do is I want you to graph x is greater than 2 on the left graph and graph x is less than or equal to -1 on the right graph. Now you'll notice that it looks like they're kind of intersecting, right? Right now from these two graphs on the left graph and on the right graph, it looks like they're heading towards each other. But if you notice the numbers, and we combine this number into one graph, this is what we have. Now if we do it the same way, on the left graph we have a greater than, so it's open circle and it's going to the right, because it's greater than. And then on the right graph on the top there, we have -1, and that's a closed circle and -1, and it's actually going to the left. And so this is an or statement. They're kind of running away from each other. So an and statement, they were going towards each other. An or statement, they are going away from each other. And so there's actually not an easy way to write these statements, so you'll always see the word or. So if we jump to the next page, we can get to some examples. Now, I'm going to kind of skip this word problem for now, and then I'm going to come back to it in just a little bit. But if we go to this bottom part here, it says solve and graph a union, disjunction, a compound inequality containing or. So this is an or statement. So you won't be intersecting, your graph should be running away from each other. So if we were to solve this, if we solve this left side and subtract 7 on both sides first, and then divide by -2, and be careful as you divide both sides by a negative, your inequality sign has to switch. You get m is greater than or equal to -3. Now if you do the same thing on the right side, you divide both sides by 12. I'm sorry, not divide, but subtract both sides by 12. You get 5m is greater than 25, and then you go ahead and divide by 5 on each side. You get m is greater than 5. Now, you either get m is greater than or equal to -3, or you get m is greater than 5. Did I do that right? Yes, I did. So if you actually graph that, you're going to find actually something a little bit interesting. So I'm going to do an orange graph and a purple graph. If you graph the orange one, m is greater than or equal to -3, we get that. And then if you graph the purple one, m is greater than 5, we get that. And you'll notice they're actually going in the same direction. Now this is a very rare case. And so what is our solution? Our solution actually is all of these guys right here to infinity. So we can start all the way from -3 all the way through, even though we have this purple graph here, because it's kind of overlapped, and because the orange one starts earlier and they're going in the same direction. So why don't you try jumping down to the bottom for number 6 and number 7 on your own, pause for a little bit, and then after a little while, check your answers, and then we'll jump back to the word problem that we skipped before. Here are the answers for example 6 and 7. The first one here, they're going away from each other, so you'll notice that it is an or statement. In number 7, it's kind of another overlap one where they're going in the same direction, so the true answer is actually x is less than or equal to 9, since x could be all of those numbers included in the purple and the yellow. So if you're ready, why don't we turn back to our word problem. It says here, a ski resort has several types of hotel rooms and cabins. The hotel rooms cost at most $89 per night, and the cabins cost at least $109 per night. Write and graph a compound inequality that describes the amount a guest would pay per night at the resort. So, the first one says at most. Now, at most means $89 is the greatest number that we will have, but it could equal $89. So x is going to be less than or equal to $89. The cabins cost at least $109. Oops, I'm sorry. At least $109. So x can be greater than that. And so we have here, if you look, x is less than or equal to 89, and x is greater than or equal to 109. Now the question is this going to be an and statement or an or statement? Now let me ask you, if you're traveling somewhere, would you book both a hotel room and a cabin, or would you book a hotel room or a cabin? You would probably book just one of those, right? Not both. And so this is going to be an or statement. And so if we create a graph, we have x is less than or equal to 89, so it's a closed circle, and since it's less than, it's going to go all the way to the left, or x is greater than or equal to 109, so since it's an or statement, it's going to go the opposite way. And so that's where our word problem is. I know this was a lot to take in. So why don't you go back, rewind the video if you need to, and come to class the next day with any questions.